Hi girls, let us have some problems to be done on the chapter of trigonometry. The problem here given is if cot theta equals to 7/8, evaluate. Number one, it is given as 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. Okay, let us draw a triangle first. This is a right angle triangle. Let us say A, B, C. This is 90 degrees. And the side opposite to right angle is called as hypotenuse, as we discuss always. Let us say this angle A as theta. For this theta, the side opposite is BC. And adjacent is AB. Now, cot theta in terms of adjacent, opposite, and hypotenuse, we write it as adjacent by opposite, which is given as 7/8. We can take adjacent value as 7 and opposite as 8 units. We did not take in terms of 7k and 8k as multiples of some integer, as we are going to find the ratios only. Now, let us find the hypotenuse initially. From Pythagoras theorem, we can write AC square equals to AB square plus BC square. AC square equals to AB square, it is 7 square, plus BC square, it is 8 square. AC square equals to 49 plus 64. AC square equals to, it is 3, 13, 6 plus 4, 10, 11. AC equals to, we get it as square root of 113. Now, the first question here we are asked is 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta. Okay, let us simplify it by using the formula A plus B of A minus B equals to A square minus B square. That becomes 1 square is 1 minus sine square theta by 1 minus cos square theta. We shall not use the identities. We can and we may not, even because it is the very first exercise which we are doing. Let us find the values of both sine and cos. Sine theta equals to, we have opposite to theta by hypotenuse. That is 8 by root 113. Similarly, cos theta equals to adjacent to theta by hypotenuse. That is 7 by root 113. Okay, this implies 1 minus 8 by root 113 whole square divided by 1 minus 7 by root 113 whole square. That can be written as 1 minus 8. Okay, let us write down over here. Shall write here. 1 minus 8 square, it is 64 by 113. 1 minus 7 square, it is 49 by square root of 113 whole square, it is 113 again. We get LCM in the numerator as 113. 113 minus 64 by LCM in the denominator, it is also 113. 113 minus 49. Both the denominators gets cancelled. 113 minus 64, it is 49. By 113 minus 49, it is 64. This is the first one. And the second thing he asked is to calculate the value of cot square theta. Cot theta is given as 7 by 8 whole square. That is 7 square by 8 square, 49 by 64. Even if we use the identities over here, 1 minus sine square is nothing but cos square. 1 minus cos square is nothing but sine square. Cos square by sine square becomes cot square theta. That's what we got the values. Okay. Let us move on to the next problem. If 3 cot A equals to 4 check whether 1 minus tan square A by 1 plus tan square A equals to cos square A minus sin square A. That is the question. Okay. Given 3 cot A equals to 4, cot A equals to 4 by 3. Let us draw the triangle first. Shall consider A as theta. For this theta, anyway, this is hypotenuse. This becomes the side opposite to theta, and this becomes the side adjacent to theta. Now, cot theta or cot A, okay, anyway, he has given it as A. Cot A equals to adjacent by opposite, which is given as 4 by 3. Adjacent is 4, opposite is 3. Now let us calculate the value of AC by using Pythagoras theorem. AC square equals to AB square plus BC square. AC square equals to AB square, it is 4 square plus BC square, it is 3 square. AC square equals to 16 plus 9. AC square equals to 25, or the value of AC is square root of 25. It is obviously 5. Now we got the value of hypotenuse as 5. We need to remember some Pythagorean triplets: 3, 4, 5, 25, 24, 7. Similarly, 6, 8, 10. Like this, we need to remember some Pythagorean triplets compulsory. 12, 13, and 5. Now, let us take LHS initially. Before taking the values of LHS, Let's find the values of tan, sine and cos. Tan A equals to opposite by adjacent, that is 3 by 4. Sine A equals to opposite by hypotenuse, that is 3 by 5. Cos A equals to adjacent by hypotenuse, 4 by 5. Now let us take LHS. It is 1 minus tan square A by 1 plus tan square A. That equals to 1 minus 3 by 4 whole square by 1 plus 3 by 4 whole square. 3 square, it is 9 by 16. 9 by 16. 16 is the LCM. 16 minus 9. Even in the denominator, we have 16 as the LCM. 16 plus 9. 16 minus 9, it is 7 by 16 plus 9. 25. Okay. Now let us find the RHS similarly. Our RHS is cos square A minus sin square A, cos 4 by 5 whole square minus 3 by 5 whole square. 16 by 25 minus 9 by 25. That is 16 minus 9 by 25. Anyway, it is 7 by 25. Therefore, we got LHS equals to RHS. This is the problem. Finally, we came to understand that for any value, for any angle, theta, let us say 1 minus tan square theta by 1 plus tan square theta equals to cos square theta minus sin square theta. Let us move on to the next problem. In triangle ABC, right angled at B, tan A equals to 1 by root 3. Find sin A cos C plus cos A sin C. And second one we shall write later. First, let us draw a triangle. A right angled triangle, right angled at B. Tan A for A, opposite hypotenuse adjacent. it is given as 1 by root 3, no? Okay. This becomes 1. This is our root 3. Okay, let us find hypotenuse first. Using Pythagoras theorem, AC square equals to AB square plus BC square. 7. AC square equals to AB square root 3 whole square, square root cancelable, 1 square. AC square equals to 3 plus 1, it is 4. AC equals to square root of 4, which is nothing but 2. Finally, we obtain the value of hypotenuse as 2. Let us find the values of sin A and cos A initially. Sin A equals to opposite to theta by hypotenuse, that is 1 by 2. Cos A is opposite to A by, sorry, adjacent to A by hypotenuse, root 3 by 2. Now, let us find the values for C. For C, this becomes opposite and this becomes adjacent. Hence, sin C equals to opposite by hypotenuse, cos C equals to adjacent by hypotenuse. Now the first one we are asked is sin A cos C plus cos A sin C. Sin A cos C cos A sin C. 1 by 4 root 3 into root 3, 3, 3 by 4. 1 plus 3 by 4, 4 by 4, which equals to 1. And second one we are asked to find here is cos A cos C minus sin A sin C. Cos A it is root 3 by 2, cos C 1 by 2, minus sin A it is 1 by 2 into sin C it is root 3 by 2. It becomes root 3 by 4 minus root 3 by 4. That equals to 0. Okay. Let us move on to the next problem. In triangle PQR, right angled at Q. PR plus QR equals to 25 centimeters and PQ equals to 5 centimeters. PQ equals to 5 centimeters. Determine the values of sin P, cos P, and tan P. PR plus QR is given and PQ equals to 5 centimeters. Determine the values. Okay. Let us draw the triangle first. P, Q, R. Here it is right angle at Q and the value of PQ is given as 5 centimeters. Let us say the value of PR as X, then QR becomes, you see here, PR plus QR equals to 25 centimeters. We are considering PR as X plus QR equals to 25. Then QR equals to 25 minus X. Let us apply Pythagorean theorem. That is PR square equals to PQ square plus QR square. X square equals to 5 square plus 25 minus X whole square. X square equals to 25 plus A minus B whole square. A square plus B square minus 2AB. 25 square, it is 625 plus X square minus 2 into 25 into X. Anyway, X square gets cancelled on both the sides. 0 equals to 625 plus 25, it is 650 minus 50x. If we transpose that 50 to that side, 50x equals to 650 implies x equals to 650 by 50. 13 times. That means we got the value of PR as 13 centimeters, then QR becomes our 12 centimeters. ఇందాక చెప్పాను కదా Pythagorean triplet 13, 12, 5 కూడా one Pythagorean triplet అని చెప్పేసి. Yes. Now whatever the things we want, we can find out. For this angle P, anyway, this is hypotenuse. This becomes the side opposite and this becomes the side adjacent. Now sin P equals to opposite by hypotenuse. That is 12 by 13. Cos P equals to adjacent by hypotenuse. Adjacent, it is 12 by 13. And tan P equals to opposite by adjacent, which equals to 12 by 5. These are the values, guys, and this is about the basic concepts regarding by drawing the triangles. We find the unknown side and we'll find all the trigonometric ratios, whatever we need to find. Okay. And next, we are going to deal with trigonometric ratios of some specific angles. Until then, this is Santhosh Kumar from Sims Academy signing off. Bye bye.